with your graphing homework. And so I have 3 examples to show you. This is from class. So I did y equals negative 2x plus 3. So one thing that I did that was kind of helpful was I highlighted the x value or the counter in blue. And I highlighted the recursive routine in pink. Now notice that I didn't number the counters or the recursive routine numbers. I didn't number the x-axis and I didn't number the y-axis. So I just count from 0, from the origin. So I start at a start value of plus 3, and the operation is to subtract 2. So each time I move the counter over 1, then I go down 2. And I also work backwards, going up 2 and to the left 1 counter. So each of these lines right here is a counter. So this is 0, negative 1, negative 2, negative 3, negative 4. And then I connect those into a straight line. So now we're going to try to find what the y value is at each of these counters. I put in the start value of 0 and 3. So when the counter is at 0, the y value is at 3. Next, it looks like I'm finding the y value when the counter is at negative 2. So here's negative 2 right here, and I count up 1, 2, 3, 4, 5, 6, 7. That's where I get that 7 right there. And I do that same process for the counter of negative 3, or x equals negative 3. It's up all the way up at 9. And now for the counter of 5, I go 1, 2, 3, 4, 5, and then count down. 1, 2, 3, 4, 5, 6, 7. So that's at negative 7. And we had a question mark. We thought maybe it was negative 5, and then we recounted it and it was negative 7. And if I go over to 6, then I have to go all the way down to negative 9. So if I go over to 6 on the blue line, we were also using a shortcut to check those answers, so we didn't have to use the graph. So if we put in a value of 6, that's negative 2 times 6, and we add 3, negative 12 plus 3 is negative 9. So 1, 2, 3, 4, 5, 6. That means I should go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's negative 9. Okay, let's do another example. Again, I highlight the counter in blue. Oops, looks like I started over. We're going to not do this one again, but no, I'm sorry, this is a different one. And actually, I'm going to stop this video. I'm realizing what's going on here. I'm going to open up the next video. Ignore the cartoon there. Okay, so that was one. Here's another one. See if I got a different one. Yep, this is definitely a different one. Okay, so here is another example. Y equals 2x plus 6. So I'm going to start at the 6. This is the origin, and this is 6. 1, 2, 3, 4, 5, 6. So my first point, my start value is going to be right there. And then I'm going to go up 2 and over 1. Up 2 over 1, up 2 over 1. And then I work backwards from there. I have to go down 2 into the left 1 to just make a stair-step straight line. And I connect those with a ruler. So now I'm going to fill out the table. Looks like I start at -2 with a counter of -2. So counter of -2, I go up to the line and go over, and so this should be a 2 right here. When the counter is at -4, I have to go down 2, so that's -2. When the counter is at -5, I go down 3. 1, 2, 3, 4. Excuse me, 4. So that's -4. When the counter is at -7, I'm going to go all the way down to here and look over and see what value that is along the y-axis. So I'm using a shortcut again here. Instead of counting and using the graph, I just put the value in, -7 times 2. I put the counter in right there. I replace the x variable with the value of -7. And I go all the way down. I'm going to stop this. Oops. Right at the right place. There we go. So if I go to -7 from, this is 0. -1, -2, -3, -4, -5, -6, -7. Then I'm going to have to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's where we get the -8. Okay, I've got one more to show you. Hopefully this is the right one. Yeah, it is. So this is how to graph the equation y equals -3x plus 2. Again, I'm going to highlight the counter in blue, and I'm going to highlight recursive routine numbers, or y, in pink. So I start at the -2. And I go down 3 and over 1. So that tells me that I go down 3 and over 1. And then I connect that with my ruler. So that's just stair steps, going down 3 over 1. Now I just have to fill in the table. I'll start with x equals 1, or the counter is 1. And I have to go down and count that, how many I went down. 1, 2, 3, 4, 5 it looks like. So negative 5. Again, I'm going to stop that right there. I went over 1, my counter is at 1, and I went down 5. 1, 2, 3, 4, 5. When the counter is at negative 1, I'm at positive 1. When the counter is at negative 2, I go up 1, 2, 3, 4. So the value is 4. And when I count over to negative 3 on the counter, I go up, and I'm going to stop this right there. So this is the origin. This is negative 1, negative 1, negative 2, negative 3. So I go up 1, 2, 3, 4, 5, 6, 7.